4.1 chain rule, worked out answers. This says to use substitution. I'm not a fan, so I'm going to blast through it. You can if you want. And I'm going to take turns writing dy dx or y prime. The outer one is sine, so derivative is cosine. 7 minus 5x, negative 5. And I will write it in the more commonly organized way, just to make people happy. Y prime equals, the outer one is tangent, so secant squared, 2x minus x to the third, 3x, negative 3x squared. I'm messing with this because I'm going to change it anyway. Make sure you keep your parentheses here. A lot of people toss them. All right, now we get a little bit more challenging. 2, leave it. Low, T high, minus, gonna run out of room here. High, D low. Sorry for the mess. Yeah, I probably should have done this by substitution, make it easier to see, but that's fine. Now we have 1 plus cosine x squared. We have cosine x plus cosine squared plus sine squared. So we can reduce this a bunch. Minus minus will give me positive. Cosine squared x plus sine squared x 1 over. I'm leaving this out here on purpose. Because that's cosine plus 1. So that drops and that drops. Equals 2 sine of x. 1 plus cosine of x squared. I generally leave enough room to do these problems, but on occasion, like this one, it gets a little tight. Do apologize. Cotangent, negative 5, cosecant squared, leave it. Now that's x, 2 times x to the negative first, so 2 times negative 1 times x to the negative second. Negative 2 will come out front, 10 cosecant squared, 2 over x. Yeah. Y prime equals negative sine of x times cosine of x. Which I guess I would just put the cosine of x out front. No, that's kind of weird. Could have left it on the back. Secant tan of x, tan of x. How weird is that, huh? Times derivative of the inside secant squared x. Object moves along the x-axis, find the velocity of the object. Leave it. Negative sine pi minus 4t, negative 4. plus derivative and leave the other side, 1 times cosine pi minus 4t equals negative, negative cancel, 4t out front. And v of t prime of t, derivative cosine 3 pi over 2t, 3 pi over 2, minus derivative cosine is a negative, sine 7 pi over 4 t times 7 pi over 4 equals, I could probably factor something out, but there's really no point. 3 pi cosine 3 pi t over 2 over 2, so 3 pi over 2, minus sine 7. I really should put the 7 up front. 7 pi t over 4 over 4. Yeah, I don't really like writing it that way now that I see it, but it is what it is. Find dy dx, just pure practice here. And they asked for dy dx, so I'll give dy dx back. Negative 2 x plus root x to the negative 3 times 1 plus 1 over 2 root x, because that's x to the 1/2 out front, x to the negative 1/2. Sorry if that bothers you. All right, do I want to simplify? Do I want to do anything? Not really. Negative 2. Yeah, I will distribute that. Negative 2 plus negative 1 over 2 root x. Sure, why not? I don't have to do that. I probably shouldn't. X plus root x to the third. dy dx equals negative cosecant of x plus cotangent x to the negative second times negative cosecant x cotangent x minus cosecant squared x. Get rid of all those. Equals cosecant x cotangent x plus, I could probably factor in, it might cancel. Let me see. Take out a cosecant, I'm left with cotangent x plus cosecant x, and that will cancel. Might as well. And you might be like, well, do I have to? And the answer is no, of course you don't. But if it's a multiple choice question, you got to go find the answer. Equals cosecant of x over cosecant of x plus cotangent of x. That's a lot of math. dy dx, leave it. Derivative. I don't know why I put 5 there. Times 2, that's the inside. Plus derivative, leave it. We have this tendency to factor out this stuff here. I don't think I'm going to. Yeah, I will. And then I'll combine the rest, see what happens. Let's take 2x minus 5 to the third out. That'll leave us with 4 times 2, 8x to the third plus 3x squared times 2x minus 5. You could stop there. 2x minus 5 to the third. Of course I won't. 6x to the third plus 8 is 14x to the third. Excuse me. Plus negative 15x squared. We could even factor in x squared out of that if we really wanted to, but I don't really see the purpose. Yeah. All right. dy dx. 1/2. 4 comes along for the ride. Secant x plus tangent x to the negative 1/2. Now this is where life gets fun. Secant x tangent x plus secant squared x. There's a lot of simplifying we can do here. Equals. Yeah, I'll definitely do it. 2 secant x, factoring it out, tangent x plus secant x over square root secant x plus tangent x times square root secant x plus tangent x secant x plus tangent x. Put these together, get secant x plus tangent x. I'm left with 2 secant x, I don't need the parentheses anymore, square root secant x plus tangent x. So do you have to rationalize? Again, no, you can be done, right there on the first step. But it'll be a multiple choice question. They're going to change the answer, so you're going to have to deal with that. dy dx low, d high minus high, d low 1/2, 1 plus x squared to the negative 1/2 times 2x. I'm having bad flashbacks. I remember doing all these problems. They take forever and they're a hassle. But hey, that's math. And the bottom just becomes 1 plus x squared because it's squared. And yeah. Equals square root of 1 plus x squared minus x squared over square root of 1 plus x squared all over 1 plus x squared. Now if I multiply the one on the left by square root of 1 plus x squared over square root of 1 plus x squared, I get 1 plus x squared minus x squared over 1 plus x squared. That's going to be that and that to the 3/2. So yeah, equals 1 over 1 plus x squared to the 3/2. So I'll draw it in even though I don't really have room. And then that's x to the 1/2. That's 1 plus x squared quantity to the 1/2. 1 plus x squared quantity to the 1. 1 plus 1/2 is 3/2. Whew! I really think I should get paid more for this. Just kidding, kind of. 1 plus cosine of 2x, and I can't let my brain go running off because I'll immediately make a mistake. Negative sine of 2x times 2 equals 4, negative 4. I'm going to leave the sine of 2x first. And I could distribute this, but I'm not going to because I don't see the point. I don't see that becoming anything simpler. Like over here it did, over here it didn't. A little bit of practice makes perfect on these, where you have to figure it out. dy dx equals times, the 2 is first, times times 7. Yeah, that's brutal. 7 times 3 is 21, times 2 is 42 with a negative equals negative 42. In combinations, no, I'm not getting rid of anything here. 1 plus cosine squared 7x cosine 7x. The negatives out front, sine 7x. Hideous. This will not be on an AP test. Some version of it will be, but they're not really trying to mess with you that badly. This is too long to be on an AP test. It would take half of forever. One half tangent 5x to the negative 1/2 secant squared 5x 5 equals, I'm not messing with any of this, so we just go 5 secant squared 5x over 2 square root of tangent 5x. Woohoo, I'm on a roll. Those are tough. Find the second derivative for these two. Y prime equals negative cosecant squared x. Always nice when it's just x. Y double prime equals negative 2 cosecant x times negative cosecant x cotangent x. 2 up front, 1, derivative cosecant is negative, equals 2, negatives cancel. Cosecant's 1 over sine, cosine over sine, no, has nothing to do with that. Cosecant squared x cotangent x. Y prime equals 9 secant squared x over 3 times 1/3. Y double prime equals 6 secant x over 3 times secant x over 3 tangent x over 3. General, you naughty boy. 1/3. Oh, disappointed. Cancel, cancel. 2. 2. Well, most missed problem in calculus. All right, on the value of f of g prime, yeah, whatever. What are they doing here? I have to slow my brain down and catch up with what the heck's going on here. F of G. In other words, F of G of X. I have to give a value of X. That's later. So derivative of this is going to be F prime G of X times G prime of X. So what's the best way to do it? That's the question. Funny part is I'm looking at my work and I don't have the faintest idea what I did here. Yeah, I do know what I did. I gotta write this out first. So F, I'll do their stupid little nomenclature, is 1 minus 1 over. Yeah, I'm definitely doing it this way. 1 over 1 minus X, which is 1 minus parentheses 1 minus X, which, unless I'm mistaken, is X. Yeah, so let's make our lives a little bit easier. F Yeah, that's good. I can live with that. The way I've done this before is doing the derivative of this, derivative of this. This is going to be u to the negative first. Negatives cancel. I'll get 1 over u squared, right? And then this is going to be 1 minus x to the negative first. Negative 1 times 1 minus x to the negative second times negative 1, and boom, boom. Yeah, it's all going to cancel out and get 1. So no, I'll pass. Thank you. I'll do this one the long way just to make people happy. I hope you're happy. Let's see what we got here. Do f prime of u. Yeah, I'm going to do the whole thing. I don't like the way I did this. F prime of u equals du dx plus that secant squared. This is horrible. Horrible, I tell you. No, it's not secant. It is secant squared. Let's just do it as a negative 2. Negative 2 cosine to the third u times derivative of cosine negative sine u times du dx. I don't like that. I don't like that at all. I could have done this as secant squared to be 2 times secant of x times secant of x tangent of x, which is, yeah, going to give us the same answer. Fun times. All right, let's go find du dx. Du dx equals pi, which is kind of nice. So f prime of x equals pi, negatives cancel, plus 2 pi sine of pi x over cosine to the third pi x. I'm using my maximum calculus abilities to do this. Equals, got to plug in x equals 1/4. So pi over 4 is root 2 over 2. 2's are going to cancel. Pi plus pi times root 2 over pi over 4. 1/4 is 4 pi. Cosine of 0, 2 pi and 4 pi is all 1 over 1. Fascinating stuff. Sensing a mistake somewhere here. Be with you in a moment. Oh, I forgot my du dx. Times pi, right? No, I got that. It's right there. Pi, sine of pi x, cosine of pi x, pi. Oh, I made a mistake. So very disappointed. Why do I have it as pi over x? Pi times x. Got it. So pi forced is cosine of pi forced is root 2 over 2 to the third, which is a big honking number, which is root 2 over 2. Well, it's 1 over root 2 to the third, so it's 1 over 2 root 2, which is pi plus, flip it up there, 2 times pi times root 2 times root 2 times 2, which is 4, which is 5 pi. So I thought this said pi over x, and that's where things got lost. Naughty boy. Tricky stuff, tricky stuff. I would actually really prefer to do it this way, where I sub in and off I go. But, you know, I want to show you it works both ways. Now, this one looks a little trickier, so let's see what we got here. Let's go with F. Yeah, no need for this. F prime of u equals 2. This is not going to be fun. U minus 1 over u plus 1 times u plus 1 times u prime. Yeah, I'm gonna make my life a lot easier in a minute here. Minus u minus 1 times u prime over u plus 1 squared. All right, let's find out what u prime is. U prime equals by x to -2, -2, x to -3. And while we are here, by the way, u of -1 is 1 over 1. -1 squared is 1. Minus 1 is 0. And u prime of -1 is -2 over -1 is 2. Okay. 2 times 0 minus 1 over 0 plus 1. 0 plus 1 times 2 minus 0 minus 1 times 2. 0 plus 1 squared equals -2. 2 minus 4 times 4. Wow. Nope, never see anything like that in the AP exam. Just mess with you. I'm not doing this 2 ways. I'm just doing it 1 way. You should get the same answer. So dy dx equals negative sine of 6x plus 2 times 6 equals -6 sine 6x plus 2. dy dx equals negative. I'm going to start throwing my 2 out front. Sine of 2 times 3x plus 1 times, I already got the 2 out front. Do I have to do it again? No. Times 3 equals -6 sine of 6x plus 2. Whew. To go. I hope it's 1 to go. Oh no, it's 2 to go. No, that's right. You need practice. Gonna be a long video. For 3 problems, line tangent curve, the point defined by the given value of t. Yeah, a little parametric. Equation line tangent curve of the point pi over 4. Now let's do x comma y first equals. What am I looking at here? Brain cramp. No. What in the world? My problems are wrong. Wow, I've never seen that. This is supposed to be, and I will fix this in my notes shortly. Get 1/6. Obviously, you just can't do it otherwise. So, wow. 2 pi over 6 is negative 2 pi times negative 1/6 is negative pi over 6. Sine of negative pi over 6 up here is here, and that is root 3 over 2 comma negative 1/2. So sine is going to be root 3 over 2. Pardon me. Cosine sine is going to be negative 1/2. And now I'm finding mistakes everywhere I look. Let me make sure I get this right. So this is wrong. Sorry about that. It's actually down here, which is 1/2 and negative root 3 over 2. So sine, cosine sine is negative root 3 over 2. Cosine of negative pi over 3, 6 messed with me, is 1/2. Okay, here we go. dy dx t equals negative 1/6 equals dy dt, which is negative 2 sine, negative 2 pi, sine of negative pi over 3. Got it. Over 2 pi cosine of negative pi over 3, which is, see ya, sine negative root 3, negatives cancel, root 3 over 2, over 1/2 is root 3. So I'm going tangent to the curve. Y minus 1/2 equals root 3, x plus root 3 over 2 plus 1/2. That's hard. That's really, really challenging. Fun times, but you know, what are you gonna do? All right, pi over 6. All right, so x comma y is 1 over cosine of pi over 6, which is 2 root 3 over 3, unless I'm mistaken. And 1 over, no, tangent of pi over 6 is sine over cosine is root 3 over 3. dy dx t equals pi over 6 equals dy dt secant squared pi over 6 secant pi over 6 tangent pi over 6. See ya, equals secant pi over 6 already did. 2 root 3 over 3, tangent pi over 6 already did. Root 3 over 3 equals 2. Y minus root 3 over 3 equals 2. X minus 2 root 3 over 3 minus plus root 3 over 3. Oh, my arm hurts. Okay. This is much, much more in my bullpen. All right, let's get my XY. 2 plus 3, 5, 1. dy dx t equals -1 equals 4 times -1 to the third over 4 times -1. Negatives cancel, I get 1. Y minus 1 equals 1. X minus 5 plus 1. Yes, I could simplify that, but I'm lazy. Okay, now we get into something that looks an awful lot like polar coordinates, and it is, but you just treat it like a variable. It's no big deal. So dr d theta equals product rule. Leave it. Derivative 2. Leave it. Derivative times 2 equals 2, and I am going to factor out my secant theta. Well, I'm not. 2 secant, I could factor out a 2 also, to the third, 2 theta, plus 2 secant, 2 theta, tangent, 2 theta. Nice. And then here we go with dr d theta. Leave it. Theta is a variable. 1/2 secant theta to the -1/2 times secant theta tangent theta plus, leave it, 2 square root of secant theta. Whew. My hand's cramping up a little bit here, so I do apologize if the handwriting's not great. I'm going to multiply this by secant theta over secant theta. Square root of secant theta over square root of secant theta. Why? I'm honestly not sure. I got to think this one through. Yeah, definitely going to do that. Equals theta times square root of secant of theta over square root of secant of theta times secant theta tangent theta over square root secant of theta by plus 2 square root of secant theta, which I can factor out, equals square root, and I didn't have to, with theta tangent of theta plus 2. Circle of radius 2, center can be parameterized by x equals and y equals. Show that any value of t, the line tangent to the circle, is perpendicular to the radius. Some of the psychos are who put this thing together, but okay, fine. Let's go with dy dx first. Dy dx equals dy dt, 2 cosine of t, dx dt, -2 sine of t, equals negative cosine of t. Okay. Now that's the slope of tangent line. Okay. Now the radius passes through the origin, and 2 cosine of t, 2 sine of t. So slope of the radius equals 2 sine of t over 2 cosine of t minus 0 minus 0. Tangent of t. If I multiply these together, I get -1, then I have perpendicular. So m tangent times m radius equals, oh goodness gracious, cotangent, negative cosine of t over sine of t times sine of t over cosine of t. That's cool. I'm not gonna lie. That's a good problem. All right. This asked me for just dy dt and dx dt. What's the weirdness going on here? I don't know what's going on. Oh, I see what's going on. Okay. I gotta do dy dx because it's defined weird. Dy dx equals dy dt over dx dt, which is 2x plus 7. So here we go. How do I dy dt when x equals 1? Okay, I can do that. Value when x n. Okay, I thought this was a two-part problem. When x equals 1 and dx dt equals 1/3, we get dy dt over 1/3 equals 2 times 1 plus 7. Therefore, dy dt, I'd have to multiply both sides by 1/3, is 9 divided by 3, 3. That's slick. That's an AP-esque problem. I'll throw a little curveball at you, see if you can hack it. Two curves are set across right angles, tangent perpendicular, and curve is orthogonal. The curves are orthogonal at the origin. Draw both graphs. Blah, 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 blah. dy dx equals, at x equals 0, equals 2 times cosine of 2x, which is, and that's the y equals sine of 2x. Dy dx, x equals 0, equals -1/2 cosine x over 2, equals at 0, -1/2. 4, y equals negative sine of x over 2. Two times -1/2 equals -1. Perpendicular. Graphing time. Should have color coordinated these. I feel shame. Pi over 4, pi over 2, negative pi over 4, negative pi over 2. Y equals sine of 2x. Kind of looks something like this. And then y equals sine of x over 2 is going to look something like this. Negative. Just realized I was off screen, sorry. And you can say these are at perpendicular to each other. Good luck with that and happy mathing.